Okay, welcome back. We will be talking about the separation of a liquid from a solution. So when it comes to the separation of a liquid from a solution, what is meant by solution? A solution is made out of two things, lah. Either the solid, which is known as the solid part, or the solvent, which is the liquid portion. So just now we talked about evaporation and crystallization is we are able to obtain the solid version from the solution. But let's say we want to collect the liquid portion, the pure liquid portion. How do we do? That's where we use simple distillation. So simple distillation is used to separate a pure solvent from the solution, such that we are able to, like, for example, let's say seawater, right? You don't want the salt, you want the water. How do you go about doing it? You will actually extract it from um, using simple distillation to extract the drinkable water. Okay, so this is how it goes up, where we set up the distillation apparatus. So in exam, will you be required to draw? Not really, but you might be required to indicate where the direction of the water in and out. At the same time, certain precautions to do. Like let's say number one, the thermometer bulb, which is this portion over here, has to be placed at the mouth of the condenser. So being placed at the mouth of the condenser, that's where you get the most accurate reading for the boiling point of the solvent that you want to collect. You will add boiling chips to actually ensure that the boiling is actually smooth, so that your solution right over here, right, will not be so vigorous that it actually channeled the liquid portion down. Only the gas portion should be collected in that area there. You have your water in and out, where the water in comes in from the bottom and out comes from the top, such that the condenser works in a sense to ensure that there is continuous and smooth condensation or cooling, so that the vapor, which is in a gas form, will slowly turn into the liquid portion here. And then it will be slowly collected at the end of the conical flask. So volatile liquids can also be kept in the liquid state by placing the receiver on ice, meaning this whole portion, you just put a beaker and you put it with a lot of ice. Volatile means that the liquid is able to become a gas at a very fast pace. Like your alcohol, your perfume, these are volatile liquids. Now, why do we need to have the water in from the bottom and top? Because when it have gravity, right, gravity has to push the water down so as to minimize any form of air bubbles. Air bubbles or air are generally poor conductors of heat. So we will not be able to absorb any form of heat from the vapor so as to cool it down. The salt, so when you put in the boiling chip, is to ensure smooth boiling. When the water vaporizes, it rises and enters a condenser. The second step is where the water boils and becomes vapor. The thermometer helps to measure the temperature of the vapor. That's why the bulb of the thermometer has to be at the mouth of the condenser. The water vapor is cooled and condensed into the pure liquid by the distillate or the condenser. And distillate meaning this is known as the distillate. Okay, whereas the equipment here is called the condenser. Then of course the salt solution will become more concentrated as distillation occurs, because all the water vapor or the solution gets churned out, whereas what is remaining is actually the solid. So that's why concentration tends to increase. Then finally, the pure water is collected and is distillate, whereas the solid, in this case, is the salt, right? Because salt solution will be considered as the residue, which is the remaining. Next, we look at separation of liquid and liquid. So for liquid and liquid, let's say the liquids are actually not able to dissolve into one another. So that's what is meant by immiscible. Okay, so liquids that do not dissolve in each other are described as immiscible. One very typical example is your oil and water. So what you do is when you have two layers, you will open the tap here. to allow the water to drain down. Then of course, when this layer of oil is closely reached, you turn off the tap. Now, how to ensure that it's more accurate, right? So you will just have to repeat this step. So first you pour the solution, let it settle, so as to form two layers on the tap, and let the water actually flow down. Okay. So the denser liquid will actually be at the bottom. In this case, it's water as compared to oil. And then later, you will just drain all the less dense, the more dense liquid out, and then you close the tap. So in the lab, there is a lot of different size for the filter funnel. So what you do is once you have already reached close to the tap, you just re-channel the whole filter funnel to the other smaller or more precise filter funnel, until you are very clear that it is only left at one particular layer. Okay. So the other type of separation of liquid is by their boiling point. Because some liquids, if they are able to dissolve in each other, they are soluble in each other. So the only thing that sets them apart is the boiling point. So what will happen is some of the examples are like ethanol and water, purified air, where first you have to cool the air down into a liquid, then of course you have your crude oil. So a fractionating column is added to help to ensure this process. So this is the main difference between a simple distillation, whereby a fractionating column is actually attached to the round bottom flask to allow better separation to take place. So the gas beads, right, sometimes they will have some plates or spirals in the fractionating column, has to provide this large surface area for the vapor to condense back into the liquid form and to fall back on. Now, this is important because sometimes the boiling point are very close to each other. So we only want to ensure a pure substance. So sometimes if they just happens to reach that state, the cooler glass beads will help to condense this vapor into liquid again, and it will fall back down into the residue here. Okay. So ethanol vapor will rise up the column as the solution is heated. The water vapor will first condense in the fractionating column and fall back into the flask. This is only in the event that if the state is not ready yet, then of course you have the ethanol, which has a lower boiling point than water, to reach the upper equilibrium, to reach the upper part of the column, and then it's distilled over. So at this stage, the thermometer shows actually a more of a constant temperature of 78, which is the boiling point. So one way to actually decide this, right, is to check the boiling point, that it should be consistent. Okay. When the ethanol has in the condenser, the hot ethanol will then slowly condense as it's cooled by the running water. And then the liquid ethanol will then slowly flow down to the inner tube of the condenser into the receiver. Ethanol is collected as distillate in the receiver, and when all the ethanol has distilled over, the temperature rises rapidly to 100 degrees Celsius, which is the boiling point of water. And at this temperature, the water will then distill over and can be separated slowly. So in terms of a graph, how do we go about seeing it? We will see that the boiling point of both solution will be constant, where we can see 100 degrees Celsius is the boiling point of water, and 78 degrees Celsius is the boiling point of the distillate. So this is how the graph will look like if you are required to plot the graph. Some industrial applications of fractionating column. First is to separate crude oil, because when we actually mine the oil at its raw form, it has many different purposes. So rather than waste it away, we actually try to separate it into its different components so that it can be used better for its respective use. Nitrogen, oxygen, and argon can also be obtained from liquid air. How do we do it? We get the air, we cool it, and condense it into liquid air. Then we put it towards a fractionating column, separate to its component based on its boiling point. Ethanol from fermentation of mixture of water, glucose, and malt. So this one is more on the formation of your alcohol or beer. Then finally, we look into into chromatography. So chromatography is this method of separating two or more components that are generally dissolved in the same solvent. So how is this actually done? First of all, we have this particular setup where the paper chromatography is being separated. The paper is separated into its component by the setup of a chromatogram. So the chromatogram is usually like a photograph or what. In this case, it's a filter paper, and that's where we actually want to obtain the different components. So how do we go about setting up? So let's say we have this food coloring and it's green in color. So you will take maybe a needle or a satay stick. You want to poke it at the start, okay, on the starting line, which is made of pencil. So what we do is when we will then dip the paper into a solvent. Most commonly used is water, but we use the word solvent because sometimes some of the component, the ink can only be dissolved in other solvents used up, but in this case water. And we must ensure that the colored spot is actually above the solvent level. If you put it at the same level, you will in a way contaminate the solvent with the ink dye. So the components will then separate as the solvent travels up the paper. So one key thing of how it usually works is because of the relative solubility of the components or the different, when we mean components, right, it means things that mix the ink. So the more soluble component will be able to travel faster and further up the paper than the less soluble component. This comes in from the point that identical dyes will travel up only at the same distance, producing same color. So that's how we identify. Whereas if let's say you use a different ink within the same ink, what will happen? You will also separate it because of the different solubility of the dyes that you use. So the chromatography paper with the separated component is what we call the chromatogram. So in terms of interpretation, we could see that this dye is not pure. Why? Because there is more than two components in this case. So generally, you will have a few scenario in this case over here. So let's say you have the filter paper, chromatography paper, and this is the starting point. So you have the scenario that there's only the starting component. Then you also have the thing whereby you have the starting component and there's only one dot. Then you have the third component that you have multiple dots, like this. So what is the key difference? Maybe I separate it so that it's clearer. Yeah. Okay. So these are the three basic scenarios that you can have lah. So for the first scenario, right, the reason why the component is not moving is because the ink use is insoluble to the solvent use. Do not use the word water because sometimes in the question they will say that water is not used. It's actually a different solvent. So the reason why the ink is not moving upwards is because the ink is not soluble or is insoluble to the solvent used. If you happen to see ink actually move up, okay, so what happened is the second scenario is that ink is soluble to the solvent used. It is a pure substance. That's why you only see one component moving up only. Okay? Of course, the component on the starting line is not counted lah. Then next is we will see that over here there is more than, so down here there's one, but down here you can see there's two. As compared to this one, there's none. So over here, what we will see is that there is more than two components. Hence, it is impure. Meaning it's made up of more than other kinds of ink dyes lah. Okay, over here is because there's only one component. And of course, at the start there is no component, meaning no separation. Okay, so generally this is it when you want to define whether is it pure. So for pure, this is the only one that is pure. This one is the first one we can't really tell because there is no nothing dissolved, so it's inconclusive. So inconclusive. Whereas the other one, we say a pure substance is actually impure. Why? Because there is made out of more than two components. Generally means that you have made out of two different kinds of ink. But sometimes it really depends on the question given the ink. Most of the time, one dot would represent one component. Okay. Next, we look into RF value. So the RF value is the position of the solvent reached by the spot and of the chromatogram, and it depends on how long the chromatography has been ran. So we will usually put the starting line as a start point, okay, the reference point. And what we can see is the chromatogram after a long period of time between two, right, where the longer one you will see is able to travel even further up. So how then are we able to calculate what is RF? RF is generally the ratio of the distance traveled by the substance and the distance traveled by the solvent. Okay, so that's what we meant by RF value. So when we put water, right, we'll see that the one in blue, right, the blue line, will indicate where the water or the solvent used travel up. However, the component will generally stop until a certain point, which is the one in green. Sorry, the one in green. So this is where it will stop. Okay, and then the ratio between the two of them is what we call the RF value, where you can see over at this example, where this can be 3 cm, whereas this whole thing is 4.5 cm. So the ratio of between them is the 1, whereas this is 3.5, and this is 5.2. So this is the formula between the two. Will you get the same value? Yes, you will get the same value of the RF, provided that they are using the same ink dye. And is there units for RF? There is no units for RF. Because due to the cancellation of the units as a whole. So the RF value of a substance will not change as long as the chromatography is usually carried out under the same condition, meaning same temperature, same solvent use. Why temperature? Because temperature is actually influenced by the particles movement can be influenced by your kinetic energy and therefore may move faster. So this property will also allow us to help to identify the substance of a chromatograph. So in this case, like when you perform, you want to understand the food sample X, and you already have identified different band substance like A, B, C, D. So we make it similar to like a drug test. So X is the urine test of the athlete, whereas A, B, C, D are known drugs. And when we run the chromatography, we realize that chromatography of the known drugs are over here, stated here already. So all these are stated here, which are very clear. Whereas these are the unknowns. The X is the unknowns. So how do we know what are the drugs that are found in X? What we want to do is we will, based on the unknown, which is the X, we actually cross-check using vertical lines to see if there is any form of intersection. So based on these three, we are able to see a few things lah. Number one, that the identified dyes produce spots at the same height, and that X doesn't contain A. Why no A? Because there is no intersection of A with X. No B. Why? Because even though there's one that intersect, the other component is not intersect, so it's not B. C definitely have because all the components have it. So so the urine most probably contains drug C, and D, no intersection, so D also don't have. Okay, so this is how we usually conclude whether the chromatography or the sample does it contain the banned substance. And another thing is based on the scenario that we talked about previously. We could see that A and D, they are pure substance because there's only one component. Whereas for B, C, and X, they are not pure substance. Generally, they are mixtures because you can actually see that they are made up of many different, there is more than one component for each of it, and that different color also. So we could say that X is a mixture of three dyes. So coming back to this, right, there is one question which is what is this? So we will need to do another sample of the drug to identify what is that. So chromatography can be used for colorless substance like amino acids. Where we want to analyze colorless substance, we will use a locating agent. This locating agent is like a coloring, where you react with the colorless substance to form color spots so that as scientists or what, I'm able to actually see the components and not just match it up. So some users of chromatography, given a sample, the chromatograph can actually be used to separate components of a sample to help to also identify components present in the sample, provided that these components that we want to check are already known to us. And this helps to identify the substance and also to determine its purity, because purity, if it's a pure substance, there's only one component. Finally, in terms of purity, why do we want to ensure or to understand something is pure? It's like, for example, in drug testing, so as to ensure that it doesn't contain any impurity that may influence side effect for us. And of course, chemicals that are often added in the food and beverages is also important to ensure that we only consume the things that are stated in the nutrition fact. Otherwise, it may not be safe for consumption. Sometimes it may be there are some contamination that through this testing that we find that something is not all right, and therefore it's being called back. So we will want to check also, another way to check purity is by the melting and boiling point, where we have to ensure that they have constant or fixed melting and boiling point, means they don't fluctuate. If you see that the boiling and melting point of a substance always fluctuate, it doesn't stay at one particular temperature, chances are there is some form of presence of impurities. So if there is impurities, the melting point will actually be lower than the actual one. If there is impurities, the boiling point will actually be higher for the impure substance than the normal one. Another one is, of course, performing chromatography, where there's only one component to indicate that this is a pure or impure substance. So generally, this is the idea behind a pure substance in terms of boiling and melting. So like I say, impurities decrease melting point of a solid, such that having greater amount of impurities, it will lower the melting point even further. And again, the melting point, it will fluctuate. It won't just stay at just that particular temperature. On the other hand, for boiling point, it will increase. So there's a key difference between boiling and melting point. So to recap, is your melting point is to change from the liquid state. Is to change the solid state into the liquid state. Whereas for boiling point is from the liquid state, you change to the gaseous state. Okay, so having a greater impurity, the higher the boiling point of the substance, the impurities will cause boiling to take place over a period of time. So generally how I remember is through this lah. Boiling point, melting point. Let's say this is the range for a pure substance. So what will happen if it's impure? If I add impurity, it will go wider. The boiling point and the melting point will actually be further away from each other. So this is impure. So through this visual aspect, the boiling point, because initially is this height, the boiling point for the impure substance is this height. So there is actually an increase in the boiling point when you add impurity. On the other hand, the melting point is of this height. The new melting point for impure substance is this height. So there is a decrease. So in exam, how they will ask is like they give you a range of temperature, and then you have to actually give a suggested temperature based on this argument. Okay, with that, we have already ended the separation the idea of the separation technique, where we talk about filtration, we talk about simple distillation, we talk about vapor chromatography, we talk about pure substance, impure substance, way to separate your different liquid from solid from liquid. You have to talk about crystallization, simple distillation. So do stop the video and recap at some of the techniques, as these can be individual questions. Each of the techniques are individual questions that can be tested in your exams. Okay, that's all. Thank you.